In this lecture, we're going to explore what happens if you try to directly store polymorphic objects in a collection like an array. In the last lecture, we have seen that if you assign a derived object to a base object, the data from the derived object is going to be basically sliced off. If you assign an oval to a shape, the oval part of the object is going to be sliced off, and we're going to be left with only shape data that we assign to our shape object. We saw that this was referred to as slicing in C++, and the same is going to happen if you assign a circle object to a shape. The circle information is going to be sliced off, then the oval information is also going to be sliced off, and we're going to be left with the inner shape part that we assign to our shape object here. Now, I want you to see that this can happen indirectly in ways that you might not expect. And we are going to use our inheritance hierarchy again. The base class is going to be shape. We're going to inherit from that and get oval, and we're going to inherit from oval and get our circle class here. So let's look at a piece of code. Here we are creating a bunch of objects. We have a bunch of circles and ovals, and we are setting up an array that is going to directly store shape objects. But what we are doing is storing our pre-created objects in our array here. And from what you already know, if you store objects in an array like this, this is going to create copies even if you can't see that directly. So what we have in our array here is not any kind of direct reference to the object we have on top here. These are just copies. And notice what is happening. We are copying derived objects in spots that are designed to store direct shape objects. And you might guess what this is going to do. This is going to slice off circle and oval information, and only shape information is going to be stored in this array here. So if we happen to loop through this array like we do here and try to call the draw method, this is not going to call the most specific draw method for circle or oval. This is just going to call the shape version of our draw method here. This is something I want you to see. Okay, some of you might say, what if I take my shape information in here and assign that to a pointer and then go through that pointer to call the draw method? Well, I hate to break it to you, but the moment your data is sliced off in a situation like this, you never get that data back. So even if you try and take the object and assign that to a pointer or a reference, you're never going to get polymorphic data again. The data has been lost permanently and you never get that. So even if you try to go through a pointer or a reference to manage your object that we have in this array, if we call the draw method, we won't get polymorphic behavior. We will get the shape version of our draw method called. So the data has been sliced off permanently if we store our derived objects in an array like this, or even if we directly assign a derived object to a base object. This is going to slice off the data and we will never get it back anyway. You should really know this. Okay, anytime I try to explain this, students mostly come up with this question. What if I try to store references in my array and do something like this? Now, this is not going to work, and this is not even go past the compilation stage of your program. The reason is we can't store references in a collection. And the reason has to do with the left assignability rule. You can't assign to a reference and change the reference to store somewhere else. And to really drive this home, let's look at this example here. We have a variable called a. It is of int type, and we have a 56 value inside. And we set up a reference which is going to be referencing the data we have in a. And down on this line here, we try to change the data in our reference. But this is not going to be changing where this reference is pointing to or where this reference is referencing. This will merely be changing the values in our reference here. And once we have this reference, we'll never be able to change where it is pointing again. So from this, hopefully you can understand that references are not left assignable. You can't store things that are not left assignable in an array because an array is designed to modify the data of what is stored inside. So if we set up an array like this, the compiler thinks that at some later point you will want to assign other data to what is already stored in this array. And there is a hard requirement on the data you store in your collections for the type of that data at least to be left assignable, and references are not left assignable, so we can't store them in a collection like this. If we're trying to do this, we're going to get a compiler error. But again, some of you are going to say, what if we store in pointers? Well, this is going to work. This is the basic working principle of polymorphism, going through base pointers to manage derived objects. This is going to use polymorphism, and here we will get the most basic draw method called. So if our object is a circle, we will call the draw method on the circle object. If it is an oval, we're going to call the draw method for the oval part of our object here. This is even going to work if we go through smart pointers. So if we do something like this and store in smart pointers and create our smart pointers on the fly in our initializer here, this is going to work because really a smart pointer is a wrapper on top of a regular row pointer in C++. So again, the message here is that you need to be careful on what you store in your collections. If it is a raw piece of data, your data is going to be sliced off if you store derived objects in a collection that is designed to store base class data. If you store in references, that's not even going to compile. But if you store in any kind of pointer, raw or smart, this is going to work because polymorphism was designed in the first place to work with base pointers that are managing derived objects. And this is really cool, and I want you to be aware of this. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is polymorphic objects stored in collections. We are going to reuse the code from the last lecture because we need our inheritance hierarchy here. And this is going to serve us just well. We're going to copy this. And we are going to head over in our current project and put in our code. And then we're going to open this in Visual Studio Code pretty quick. Let's do this. This is going to give us our code, and we have our shape class, which is really what we already know. We have our oval class and we have our circle class. Take a good look at this. And what we want to see is what happens if we use different kinds of setups to store objects of this inheritance hierarchy in a collection like an array. Let's go back to our main CPP file, and we are going to take out what we have in here. We're going to set up what we're going to be using in this lecture. We are going to set up a bunch of objects that we're going to be using here, basically a bunch of circles and ovals. We can close the left sidebar here and have some more breathing room. After this, we're going to set up an array which is going to store copies of this object in this array here, which is called shapes1. And after this, we're going to try and loop through this array and try to do things with it. For example, we can say for shape, and we may want to call the draw method on our copy here. So for example, we can say s and say draw. We're going to see what happens here. And let's say references because we don't want copies in our range-based for loop here. So this is going to avoid copies we do in this loop. And we're going to be directly referencing whatever we have in this array here. Now, what do you expect to get? We have derived objects in this array, and with the setup we have here, because we are using virtual functions, one would expect to get polymorphic behavior. So here we would expect to get the draw versions in circle and oval to be called, but that's not what is going to happen. We're going to see that we're going to be calling shape versions of our draw methods. Let's try and build and show you this. We're going to build with GCC, our favorite compiler. The build is going to go through. We can kill this and bring up a PowerShell window to allow us to run our program. We're going to say rooster here, And you're going to see that we are drawing circle 1 over 1, circle 2 over 2, circle 3 over 3, but we are calling the shape versions of our draw method. And the reason is we are slicing off derived class information in our objects the moment we try to make a copy and copy in a spot that is designed to store objects of the base class. So this is basically what we saw in the last lecture on the slicing, but it is disguised because we are storing data in an array. And when you store data in an array like this, you're going to be making copies and storing copies in your array. And in any copy you make, you're going to be basically slicing off oval and circle information and only storing in shape information for our objects here. This is what the compiler is going to do. And to really try and prove this, we can try and print the size of these objects and see the sizes of these objects in this array here when we loop. So for example, we can say stdc out size of circle 1. Do we have circle 1? Yes, we do. So we're going to say size of circle 1 here, and we're going to put its size information out here to be seen by everybody. We're going to say size of circle 1, and we're going to print it out. And we are also going to print the size of whatever iteration we are at in our loop here. That's the first thing we're going to print, and we're going to say size of object, and we're going to say size of s. This is going to do. And we're going to loop and see if the information we have on the outside is the same as we have on the outside. Again, we are printing this information on the direct object, which is really not yet in our array. And in fact, we can bring this in front of our array to make this super clear. And in our loop, we are printing information on a copy that we have in our array, because this is the real deal we have in our array, because this is a reference. Hopefully this is going to make sense and prove to you that we are going to be working with derived objects, and that the data is going to be sliced off if we copy the data in our array here. This is what I want you to see. So we're going to run this again. We're going to pass this through GCC. The build is going to be good. We can clear and run Rooster. Now let's look at what we have here. Size of circle 1 is 56. But you're going to see that the size for all our objects in our array has shrunk to 40 because derived class information has been sliced off the moment we copied our data in our array here. And this is what I want you to see. And I think we can even see this if we go through our debugger. For example, we can put a breakpoint here and open our run tab. And if we try to run our program through the debugger, the build is going to be good. And the binary is going to be passed into our debugger. And we're going to hit our breakpoint in a minute. So let's wait for this. And we have hit our breakpoint here. But what we can do now is look at our local variables on the left. Let's look at our array. The array is called shapes. And if we go up, we're going to see our shapes1 array. And we're going to see that we have 5 indexes here because we have 6 elements inside. We can expand and see what we have at index 0. And you're going to see that we just have description data because this is a shape. If we go back in our class, we're going to see that the only thing we have in our shape class is really a description member variable. And it is what we see in our array here, just description information, because this is a shape object. And we have lost or derived class information. And this is really cool. But if we go on top and, for example, expand circle 1, we're going to see that we have a novel part of us and we have a shape part of us. But these things have been stripped off in our array when we slice off the data from derived objects to only store shape information in our array here. I hope this makes sense now. We're going to kill our debugging session because we don't need this anymore. And we are going to comment this out and see some other things. So we are going to comment with our data here. We're going to say, if you store row derived objects in an array, which was set up to store base class object, the data is going to be sliced off. This is something I want you to know. But some of you are going to say, what if we store in references? Okay, so let's try and do that. We're going to set up a piece of code like this, and we're going to set up an array called shapes2. And this array is going to be basically storing references to the objects we have on top here. And we're going to see what happens. You notice that we have a squiggly line already. And this is saying this is not going to work because references can't really be stored in collections. Again, as we saw in the slides, the reason is because references are not left assignable and they can't be stored in a collection like an array here. The basic requirement on the types that you can store in your array is that they have to be left assignable, and our references are not left assignable, so this is not going to compile. If we try to build our program, we're going to see that we're going to get weird compiler errors. And the build is going to finish with errors. And if we go up, we're going to see that declaration of shapes2 as array of references. And this is not allowed. You can't have an array of references in C++. And this is the reason why. So we're going to get a compiler error here. Okay, so now you know this, but some of you are going to say, what if we go through pointers? Well, that's going to work because polymorphism through virtual functions was basically designed to work with base pointers that are managing derived objects. And this is what we have here. So if we look, we're going to be getting polymorphic behavior. And if we call our draw method on our pointer here, we're going to get the most specific draw method called. And this is what we want. So we're going to try and build this again and show you that this is going to work. The build is going to be good. We can clear and run rooster. And we're going to see that we are going to be looping around. And if we call the draw method, we're going to call the oval draw method, circle draw method, oval draw method, circle draw method. This is basically what we want. And we are going through base pointers to really use polymorphism here. This is even going to work if you go through smart pointers. So let's comment this out and set up another example to really drive this home. You can really use any kind of smart pointer. You can use unique pointer or shared pointers. So here we will just be storing in shared pointers because this is easier to handle. And we're going to head over to the top and include the memory header. If you remember, if you want to use smart pointers in C++, you will have to include the memory header, which brings in the data to set up smart pointers in your C++ code. So this is going to look good now. And if we build, we're going to get the most specific version of our draw method called through polymorphism that is using virtual functions here. So let's build and show you that this is going to work. The build is going to be good. We can clear and run rooster, and we are going to get our versions of draw called, the version for circle and the version for oval, because we are using base pointers to manage derived objects here. And our class inheritance hierarchy is using virtual functions for the draw method here. So this is going to work. This is really all I wanted you to see in this lecture. You should be careful if you try to store derived objects in an array that was designed to store base class data. If you are using raw data, you're going to get slicing, and you really need to be aware of this because you want to have derived class information. If you try to store in references, this is not even going to compile because references are not left assignable. But this is going to work if you use raw pointers or smart pointers, because polymorphism was basically designed to work with base pointers or references that are managing a derived object, which uses polymorphism. We are going to stop here in this lecture. In the next one, we're going to learn about the override mechanism in C++. Go ahead and finish up here and meet me there.